I know, everyone is excited that I didn't turn the page first. So that means I get more, right? Think of the ones I haven't asked yet. They didn't get a chance to help me. And if I already asked you, you go, yeah, ask them. They haven't been asked yet. So like Clarissa, what should I do in the numerator? Well, you do. That's called homework. That would be the last page of the packet. So, number 9, Clarissa. Thank you. I know. I set that up for you to be miserable at me. I'm okay. I can handle misery. I'm going to go through it. Clarissa, what do I do for the numerator? And what do you get? Okay, same thing with the denominator. Shh. So let's say you're not in the mood to keep going. I am. So then you can watch the video later, right? But don't ruin it for others. And then do you see something removable? Okay, so right away I'm going to write down the domain. So the two numbers x cannot be are positive 3 and 1. And what removed creates a whole. Just think that you're not ready yet, right, for the quiz next time I see you, right? On Monday morning. That we need to do this together. That we're just like babies on understanding how to do this. So I removed it. So what's left over is x subtract 7 and x subtract 1. Sarah, how do I find the x-intercepts? What are they?
You look at the numerator.
Yeah, and so what's the 0 of the top?
3 and
So we remove the 3. 3 is a whole.
so 7.
So what's left over is only 7, and it's odd. What's the y-intercept?
7.
Excellent. So you plug in 0, and negative 7 divided by negative 1 is 7. Where's the vertical asymptote?
S equals 1.
Excellent. Do you see the domain restriction? 3 creates a whole, and 1 creates a vertical asymptote. Why is there no horizontal asymptote?
Because the power term is like the same.
Because the top is more powerful, or is it the same? What? Rosie was like she didn't want to do it, and now she said, you made a mistake. Or is it the same? So what don't we have in this case? No what? No oblique. So why is there no oblique? Because the powers are the same. So how do I find the horizontal then? Why is there no oblique? I'm waiting. You ready? Is the top more powerful? No oblique. Look at this, right? All on YouTube, right? You're all like not into this, and then you got into it. So, as soon as I make a mistake, you're like on it, right? That's what gave you energy. All right, Sarah, how do I find the horizontal? So what's the power term on top? X. What's the power term on the bottom? And divide, and what number do you get? Now, let's say you divided x squared over x squared. You'd still get 1. Awesome. So is there a hole? Yes. So what do I do to find the hole? Is where there's an x, I plug in 3, and then simplify it. So, oops, that's a subtract sign. So 3 take away 7 is negative 4. 3 take away 1. So divide, and where's the y value? All right, we're ready to graph this. Not Genesis. Jimena, where do I start first? I know, she got nervous. You said you already asked me, right? All right, Jimena, where do I start? Where am I x in it? Well, I have 1. Where is it at? Let's do that, right there. What else do I plot on my graph? Where's that? Got it. What else do I plot? So the vertical's at what number? So find 1. Remember, no slanted, no oblique. The horizontal is at 1. And we have a hole. Where's our hole at? 3 and negative 3 and negative 2, right? That's it. We now can do the easy part of graphing it. So one end is going to the vertical asymptote, hop over the hole. The other end goes to the horizontal asymptote. So the right end behavior and the behavior at the vertical asymptote. On the other side, we already have a point. One end goes to the vertical, and this is going to curve to what? So notice the end behavior there, and you're done. Number 10, when we practice together. Kay, it sounds like you need to practice with me. Be energized. Kay, how do I factor the numerator? Let's do that. Factor out an x, and you get x subtract, or x squared subtract 1. The denominator? Kay? Can you factor the bottom for me, Kay? Or you can ask for help. What two numbers multiply to 1 and add to negative 2? No, Kay. I just got to make sure I hear her, or I have to keep saying her name on the internet. So, how do I factor it? Negative 1 and negative 1. Do you know you could write that as negative 1 squared because it repeated? And that's important because it's going to help me understand the vertical asymptote. Okay, let's keep going. We're not done factoring. Nick, do you see where I can factor further?
X squared minus 1 negative 1.
So what is that?
X parentheses x negative 1 parentheses x positive 1.
So you tell me I have x plus 1 and x minus 1?
Yeah.
Now, I'm going to tell you, I now kind of want to write that separately. Do you know why I want to write that separately?
So you can cross it out.
So, do you know it's removable, right?
Yeah.
Now, this is going to be tricky. You ready to listen? Do you see how you removed x subtract 1? You listening? This is going to be tricky. Listening. X subtract 1 did not completely remove. Is there still an x subtract 1 that remains?
Yes.
That means there's no hole there. Because what remains is a vertical asymptote. So, if it's completely removed from the bottom, it creates a hole, but it didn't completely remove. Something still stayed. And what stayed on the bottom creates a vertical asymptote. So, because it wasn't completely removed from the bottom, it didn't create a hole. All right, I'll let that absorb. So, what I'm left with is x squared plus x over x subtract 1. So, the domain restriction, x cannot equal 1. There's only one number x cannot be. When I look at the x-intercept, what's left over on top? I get 0 and negative 1, and they both are odd. When I plug in 0 for x and solve it, I get the answer 0. Now, I'm not going to make this mistake. Rosie, help me. Is there a horizontal asymptote here?
No.
Why not?
Because the top is more powerful.
Exactly. Don't make me. So there's a what type of asymptote instead? Oblique. And how do I find the oblique? Is by dividing. So I look at the denominator. Can I use synthetic? What's the 0 of the bottom? And then I use 1, 1, and 0. 1x squared, 1x, and 0. Divide. The remainder doesn't bother me. What is the oblique in this case? Y equals x plus 2. We're ready to graph. So to graph this, we're going to start with the intercepts at 0 and negative 1. We have a vertical at positive 1. And we have an oblique at y equals x plus 2. So find where 2 is, and what's the slope? Up 1 and to the right 1. Draw a dashed line. So now I need to graph it. Do you notice we have 2 points on the left, but we have no points on the right of the vertical asymptote? We're going to have to find a point to the right when I do the curve. But on the left, I understand. So I'm going to take the one on the furthest right, and what's the behavior at the vertical asymptote? It's going either to negative infinity or positive infinity. I know that they're going to cross over. So I know it crosses over, and I know it's going to cross over. See how I crossed over twice? And then what's going to happen to this behavior? It's going to follow the oblique. So notice it crosses over twice, and the behavior and the behavior. What happens at the vertical? What happens at the oblique? That gives you the ends. In the middle, I understood it crossed over twice, so it gives me my curve. What don't I have up here that I need? What would be a good x value? So I'm going to plug in 1, 2. I think 3 will be on my graph. If I plug in positive 2 and it's not on my graph, I go to the next x value. So 3 squared plus 3, and then 3 take away 1. So 3 squared plus 3 is 9 plus 3 divided by 2. So what answer does that give you? So we have another point. What's a point I can curve through? Is 3 and 6. So 1, 2, 3, 4, 5, 6. So now I have a point. It's above the oblique. Once I have a point to curve through, understand the behavior. One side is going to follow the oblique, and the other side is going to follow the vertical asymptote. And you have your rational function. Number 11. Step 1 in number 11 is to factor. Corey, how do I factor the denominator?
You factor out of 2x.
Close. What's the biggest number that goes into both?
4x.
4x. And when I divide, I'm left with x minus 2. That's it. Corey, do I have an oblique asymptote here? No. You know why?
Because the bottom
Is more powerful, isn't it? Now, is the bottom more powerful? Right away, it's y equals 0. The domain restriction. What can x not be from the denominator? And the two numbers are 0 and 2. So then what are the vertical asymptotes then? Nancy, what would you say the vertical asymptotes are? At what numbers? Yes. So at 0 and 2, they both are odd. Do we have any holes here? No, because nothing removed. I'm not going to worry about the range. Look at the numerator. Is there any variables on top? So there's nothing that makes the numerator 0. There's no x-intercepts. If I plug in 0 for x, I get 16 divided by 0. Again, no y-intercepts, because there's an asymptote over there. So we're going to start our graph, but we need to do a table of values to continue. Okay, so how many curves are there in this picture? One on the right, one in the middle, and one on the left. What that tells me is I need a point on the right. So I'm going to plug in 4, I'm going to plug in 1, and I'm going to plug in negative 2. I just picked a point, an x value to the right, an x value in the middle, and an x value on the left, because I need points to curve through. So when I plug in 4, what answer do you get? So it's 16, then 4 times 4, and then 4 take away 2. Now I'm not going to multiply it all out, because do you see how the 16s will divide out? So what are you left with for an answer? 4 and 1/2. Can you find that, where 4 and 1/2 is? What's the curve going to do at 4 1/2? So it's going to follow the horizontal, and then follow the vertical going up forever. What happens when I plug in 1? So when I plug in 1, I get 16. When I plug in 1, I get 4, take away 8. And then when I divide, I get 1 and negative 4. Do you know that these are odd asymptotes? So on one side it goes up forever, on the other side it goes down forever. Do I now have a point to curve through?
Yes.
Now, why do I know both sides go down? Because the other direction would be to cross over and there's no x-intercepts. So, both sides go down. If this is odd, then the other side goes up. One more time, I'm going to find a point to plug in. So, I'm going to plug in negative 2. 4 times negative 2 is negative 8. Negative 2 and negative 2 is negative 4. So again, I get 16. So I get negative a half. So at negative 2, I get negative a half. Okay? What did I do wrong? Oh, when I plug in negative 2, I get a positive 8 and a positive 4. That's not negative a half, but positive a half. And why does that make sense? Because it needs to be above. So I double check the signs, understanding the behavior at each vertical asymptote. So I know the behavior at the vertical, and I know the end behavior is following the horizontal. Do you see the sad face that you're feeling right now, graphing rationals? Do you see the 2 eyes and the frown? That's your inner child right now, graphing rationals. See it? Poor little thing, right? Darn it. 12, last one, and I mean it for this lesson. So, step number 1. Do you know how to factor? I'll do it. So what do they all have in common? X. What's left over is x squared plus 4x minus 12. Look at the denominator. Don't cross your arms yet. We're not done, right? Number 12. The bottom is a difference of squares. X plus 2x minus 2. Not done yet. Look at the numerator. 2 numbers that multiply to negative 12. Add to 4. 6 and negative 2. So already I know my domain restriction. Looking at the denominator, what are the 2 numbers x cannot be? Positive and negative 2. Is there something removable? Is it completely removed, or is there still an x subtract 2 on the bottom? Completely removed. So what's the x value? What's the 0 of the factor that removed? Positive 2. The x-intercepts are 0 and negative 6. The y-intercept is 0 divided by, whatever, is 0. We have a vertical asymptote at negative 2. Do we have a horizontal or oblique? Because the top is more powerful. How do I find the oblique? Is by doing long division. Let's see if I got room. Actually, I can do synthetic with the remove. See this? So I can use negative 2 and make it easier. That's better, right? But I got to go x squared is 1, and x times 6 is 6x. So this is 1, and this is 6, and this is 0. So the remainder is not what I'm worried about. What's the oblique asymptote? Is y equals x plus 4. All right, we're ready to graph. On the graph, can you find 0 and negative 6? The vertical asymptote is at negative 2. We don't have a horizontal. How do I graph the oblique? I start at 4, and then I go up 1 and to the right 1. we have a hole. Did I find the y value of the hole yet? So I got to plug in what number to find the y value? 2. So 2 and 2 plus 6 is 8. And 2 plus 2 is 4. So 16 divided by 4 is 4. So the hole is at 2 and 4. So 2 to the right and 4 up. I have a hole. Now I can finish the graph. So on one side it curves up and follows the oblique, and on the other side it follows the vertical. We have a point. On one side it curves and follows the vertical asymptote, and on the other side it follows the oblique. Alright, now I mean it. This lesson was on obliques. When the degree on top is one bigger, it creates an oblique. We find it by dividing. And we learn how to analyze and graph rationals by practicing correctly, together, not giving up. Alright, now I mean it. Mr. G Math. Over and out.